Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss a solution of the mock test 2, okay, COMEDK 2024, physics part 1, question number 1 to 30. So if you haven't downloaded the question paper, please join the WhatsApp channel which is given in the description box. Okay, so in there you will get the question paper and detailed solution. Yeah, so let's start. Question number 1. Which of the following physical quantity changes when a particle moving with uniform velocity? Here particle moving with uniform velocity, right? So when particle is moving with uniform velocity, right, speed does not change, right? Speed is the magnitude of the velocity, right? So speed does not change, right? Velocity anyway does not change, right? And particle is moving with the uniform velocity, so acceleration of the particle is anyway 0, right? So these two does not change, right? So only the position will change, right? So the correct option is A. Yeah. Next one, question number 2. When water is heated from 0 degrees Celsius to 10 degrees Celsius, its volume. So its volume first decreases, then increases, right? Isn't it? Here, as the temperature increases, right? Here, volume of the water first decreases, okay, then it will start to increase, right? So this is the point where the density of the water is highest, right? At 4 degrees Celsius, right? At 4 degrees Celsius, density of the water is highest, isn't it? So then volume will increases. First decreases, then it will increase. So the correct option is D. Question number 3. The number of significant figures in expression 4.327 divided by 2.51 here gram per centimeter cube is. Okay, so 4.327 divided by 2.51 is 1.721 and so on. Okay, so we have to keep the answer in 3 significant figures, right? So in the question, the least significant figures is 3, right? So we have to express the answer in 3 significant figures only. So the correct option will be, the correct answer will be 1.72 gram per centimeter cube. Okay, so 3 significant figures. The correct option is C. Next question, question number 4. The ratio of the dimensions of Planck's constant, and that of moment of inertia, okay, and that of moment of inertia is the dimensions of. Okay, so what is the dimension of Planck's constant? We know that energy E equal to h into nu, right? Energy of the photon is equal to h into nu. Nu is frequency, right? So what is the dimension of the energy? M L square T to the power minus 2, right? So dimension of Planck's constant is energy, okay, into dimension of the time, right? Into dimension of the time. Energy divided by frequency. Frequency is 1 by T, right? So energy, dimension of the energy into dimension of the time divided by, so what is the dimension of the moment of inertia? So that will be M L square, right? So what is the dimension of the energy? M L square T to the power minus 2 here into T, right? So M L square T to the power minus 2 into T divided by M L square. So now M L square will get cancelled. T to the power minus 2 into T is T to the power minus 1, right? So this will be T to the power minus 1. T to the power minus 1. So T to the power minus 1, right? So this is the dimension of the frequency, right? So this is the dimension of the frequency. So the correct option is B. Okay, yeah. Next question, question number 5. Figure shows x of t, y of t diagram of a particle moving in 2 dimensions. If the particle has a mass of 500 gram, that is half kg, okay, half kg. The force acting on the particle is, okay, we need to find force acting on the particle. So if you look at the option, we need to find force acting on the particle and in which direction the force is acting on, right? Okay, so look at xt graph. In xt graph, here the graph is linear, right? So that is, the velocity is constant, right? If the velocity is constant, acceleration is 0. So force acting on the particle along x-axis is 0, right? Force equal to m into a, right? M into, okay, force acting on the x-axis, acting along x-axis, force acting along x-axis on the particle, right? So Fx is equal to 0, right? 0. Why? Because acceleration is 0, right? Why acceleration is 0? Because velocity is constant, right? Yeah. So look at YT graph. Here the graph is parabolic, right? The curve is parabolic, isn't it? So that is, velocity is not constant, right? What does that mean? A particle has acceleration, right? If velocity is not constant, then particle is moving with some acceleration, right? So we need to find that acceleration. Yeah. So now here the acceleration of the particle at t equal to 2 seconds, right? So how much distance particle has traveled? 4 meter, right? Isn't it? So apply second equation of motion, s equal to ut plus half, okay, uyt plus half ay into t square. Okay, so now s equal to 4 meter, right? Uy is 0 because it starts from the origin, right? At origin time is 0 and uh, the displacement is also 0, right? Yeah. So now t is 2 second, s is 4 meter. So now 4 equal to half ay into t square. T square is 4. T equal to 2 second. T square is 4 second square. So now 2 2s are 4, right? So now ay is equal to uh, 2 meter per second square. 2 meter per second square, right? So this is ay. Okay. So let us find force acting on the particle, right? So force acting on the particle along y-axis is equal to m into ay. So now Fy equal to m is half kg into ay is 2 meter per second square. So now 2 will get cancelled, which is equal to 1 Newton. So the correct option is A. Okay, 1 Newton along y-axis. Yeah, next question, question number 6. A stone of mass 1 kg is lying on the floor of a train which is accelerating with 1 meter per second square. Okay, train is accelerating with 1 meter per second square. The net force acting on the stone is, okay, we need to find net force acting on the stone. Train, okay, this one is dead easy question. Still I am solving this, okay, because we can solve this question in two ways, right? One taking pseudo force and accelerate, and then from the ground frame of reference, right? 1 kg block, train moving with acceleration 1 meter per second square, right? So from the ground frame of reference, block is also moving with acceleration 1 meter per second square, right? So the force acting on the block is equal to 1 kg into 1 meter per second square, which is equal to 1 Newton, right? So in which direction the force is acting on? This way, right? Okay, so from the accelerating frame of reference, right, that is the man inside the train, okay, so for him the block is at rest, right? So but we need to find the force acting on the block, right, isn't it? So in this case apply pseudo force, right? Pseudo force, which is opposite to the direction of the motion of the train, right? Now here F equal to m into a, pseudo force, right? M is 1 kg, again 1 meter per second square equal to 1 Newton. So the correct option is B. Okay, yeah. Next question, question number 7. Two blocks of masses 10 kg 20 and 20 kg are connected by a massless string. So this is the massless string, okay, and are placed on a smooth horizontal surface as shown in the figure. Okay, so this is the smooth horizontal surface, okay, smooth horizontal surface, smooth horizontal surface, right? if a force 600 Newton is applied, here F equal to 600 Newton, okay, 600 Newton is applied to 10 kg block, then the tension in the string is, okay, we need to find the tension in the string. So when you apply force on 10 kg block, what happens? Tension will develop, right? Tension will develop, isn't it? Okay, so here both blocks are moving with the same acceleration, right? Because the string is connected to the both blocks, right? So now find the acceleration of the system. System is block, two blocks plus string, right? Anyway, string is massless. So find the acceleration of the system. Acceleration of the system A equal to applied force divided by total mass, that is m1 plus m2. So now acceleration A equal to 600 Newton divided by m1 plus m2, that is 30 kg. So now this is equal to 20 meter per second square, right? 20 meter per second square. Okay, now we got the acceleration of the system, right? So acceleration of the 10 kg block is 20 meter per second square. Acceleration of the 20 kg block is also 20 meter per second square, right? But we need to find the tension in the string, right? Okay, so now let us draw the free body diagram for 10 kg block. Here 10 kg block, okay. So what is our frame of reference here? This one, right? Y and X, right? Okay, so now the normal force acting on the 10 kg block is N, then 10 into G is 100 Newton, okay. So then 600 Newton force is applied, okay, and then tension is T, right? Now apply Newton's second law of motion. Anyway, there is no vertical motion, right? So acceleration along vertical is 0, right? So then here the applied force 600 Newton minus T equal to mass of this block or 10 kg block into the acceleration of the 10 kg block. Apply Newton's second law of motion. Here F minus T is equal to 10 kg into A, right? So F is 600 Newton minus T is equal to 10 into A. A is 20 meter per second square. So 10 into 20 is 200. So now T equal to 400 Newton. The correct option is D. Okay, even if you check for 20 kg block, again you will get 400 Newton only, okay, because T equal to 20 into A is 20, 20 into 20 is 400, right? So the correct option is 400 Newton. Next question, question number 8. If the pressure and the volume of certain quantity of ideal gas are doubled, then its temperature. We know that ideal gas equation, PV equal to nRT. N is number of moles, right? So now here pressure and volume of the certain quantity of ideal gas is doubled. So pressure is doubled, okay, sorry, not halved, doubled. So 2P into volume is also doubled, 2V, which is equal to nRT dash, right? So this will be 2 into 2, 4, right? So 4PV. 4PV is equal to nRT dash, right? So PV equal to nRT, right? PV equal to nRT. So now 4 times nRT is equal to nRT dash. So nR will get cancelled, right? So now T dash equal to 4 times T. So that is its temperature becomes 4 times. The correct option is D. Next question, question number 9. A system is said to be in thermal equilibrium if system is said to be in thermal equilibrium, then the macroscopic variables like volume, pressure and temperature do not change with the time. Okay, so the correct option is A. The macroscopic variables do not change with the time. Next question, question number 10. For perfectly rigid body, Young's modulus is infinite and bulk modulus is 0. This one is wrong, right? bulk modulus is also infinite, right? Isn't it? Okay, let's see how. We know the relationship between Young's modulus, bulk modulus and modulus of elasticity, right? So that is Y equal to 3K into 1 minus 2 eta. Eta is modulus of elasticity, right? So Young's modulus is proportional to K, right? It depends on K, that is bulk modulus, right? So in perfectly rigid body, Young's modulus is infinity, right? Young's modulus is infinite. So therefore bulk modulus has to be infinite, right? So the correct option is B. Okay, the correct option is B. Yeah, Young's modulus, sorry, not B, sorry, not B. So correct option is C. Young's modulus is infinite, bulk modulus is also infinite. Yeah. Next question, question number 11. Spherical balls of radius r are falling in a viscous fluid of velocity v. Okay, spherical ball is falling through a viscous fluid. Okay, velocity of the ball is spherical ball is v. The retarding viscous force acting on the spherical ball is, okay, so what is the viscous force, expression of the viscous force? F equal to 6 pi eta rb, right? Eta is coefficient of viscosity, r is radius of the spherical ball, v is velocity of the spherical ball in viscous medium, right? So let's check the each option. The viscous force acting on the spherical ball is directly proportional to r but inversely proportional to v. Wrong. So it is also directly proportional to v, right? Directly proportional to v, right? So option A is wrong. Directly proportional to both radius r and velocity v. Correct. Both radius r and velocity v. Okay. Next question, question number 12. For which of the following does the center of mass lie outside the body? Okay, pencil is like a rod, right? Isn't it? The shape of the pencil is cylindrical, right? So the center of mass lies within the body, right? In the cylinder, center of mass lies within the body, right? So first option is wrong. Second option, a shot put. Shot put is a spherical shaped, right? Sphere, right? So center of mass lies within the body, right? So the correct, okay, option B is also wrong. Then option C, dice, a dice. Here, a dice is in cubical shape, right? So center of mass lies within the body, right? So the option C is also wrong. Let's check option D, a ring. Yeah, so this is a ring, right? Ring, not exactly ring, okay, ring. So center of mass lies outside the body, right? Center of mass lies at the center of this ring, right? Isn't it? So center of mass lies outside the body here, right? So the correct option is D. Yeah. Next question, question number 13. A 10-meter long steel wire has mass 5 gram, that is 5 into 10 to the power minus 3 kg, okay? 5 into 10 to the power minus 3 kg. If the wire is under tension of 80 Newton, okay, T equal to 80 Newton. The speed of transverse wave on the wire is, okay, so the speed of the transverse wave, V equal to root of T divided by mu. So what is mu? Mu is linear mass density, right? What is linear mass density? Mass per unit length or mass by length. So now V is equal to root of AT divided by mu is mass per length, right? Mass is 5 into 10 to the power minus 3 divided by length is 10 meter, 10. So now solve this, you will get V equal to 400 meter per second. The correct option is C. The time period of an artificial satellite in a circular orbit of radius r is 2 days and its orbital velocity is v0. If time period of another satellite in a circular orbit is 16 days, then, okay. So here, okay, if you look at the option, so they are asking you to find radius of the orbit and orbital velocity, right? Okay. So first find radius of the orbit. Let us find radius of the orbit, then orbital velocity. Okay. Yeah. Apply Kepler's third law of planetary motion, right? So Kepler's third law of planetary motion, that is t square, is directly proportional to r cube. T is time period, okay, or yeah, the time period, and then r cube or r is the distance between the planet and the satellite, or you can call it as the radius of the orbit, right? Okay, so here the artificial satellite revolving or moving in a circular orbit of radius r. So now its time period is 2 days, right? Okay, so t equal to 2 days when the radius is r, or radius of the orbit is r. So we need to find the radius of the orbit r dash when t equal to 16 days. Okay, so now here r dash divided by r is equal to t to the power 2 by 3, sorry, t dash to the power 2 by 3. So this is t dash to the power 2 by 3 by t to the power 2 by 3. So now r dash is equal to t dash to the power 2 by 3, that is 16 to the power 2 by 3, right? So 16 divided by 2 to the power 2 by 3 into r. So now solve this, you will get r dash is equal to 4r. So the radius of the orbit is 4r, right, for second satellite, right? So c and d are eliminated. So let's find orbital velocity, right? So what is the expression of orbital velocity? V naught is equal to root of gm divided by r, right? So from this I can conclude that V naught is directly proportional to 1 divided by root r, right? So this is small r, okay, 1 divided by root r. So now here V naught dash divided by V naught is equal to root of r1 divided by root of r2. r1 is r, we need to find V naught dash, r2 is 4r, right? So V naught dash is equal to V naught, here root of r2 is 4 times r, right? So substitute, you will get V naught divided by 2. So the correct option is B, okay. Radius of the orbit is 4r, and orbital velocity is V naught by 2. Next question, question number 15. Two spheres of masses m and m are situated in a air, and the gravitational force between them is F. The space around the masses is now filled with liquid of specific gravity 3. The gravitational force will now be. So gravitational force does not depend on the medium, right? Isn't it? So the gravitational force between the two masses is same. So the correct option is B. Okay, F only. Next question, question number 16. The dependence of acceleration due to gravity g on the distance r from the center of the earth assumed to be sphere of radius r of uniform density is shown in the figure below. Okay, we need to find the correct graph, okay, between g versus r, right? Here the acceleration due to gravity varies with the r from the center, right? Okay, so what is the acceleration due to gravity when you move below the surface of the earth? So g dash is equal to g into 1 minus d divided by r, right? So now g dash is equal to g is acceleration due to gravity on the surface of the earth, okay, g into r minus d divided by r. So r minus d, take r minus d as small r, okay. So now g dash is equal to g into small r divided by d. So as you, small r divided by capital R, it is the radius of the earth, okay. So that is, as you move away from the center, as you move away from the center of the earth, what happens? Acceleration due to gravity increases linearly, right? So it increases linearly. So g dash, right, is directly proportional to r, right? G dash is directly proportional to r. So now when you move away from the surface of the earth, right? Okay, so now acceleration due to gravity when you move away from the surface of the earth, right? So G dash is equal to Gm divided by R plus H whole square. Take R plus H as small r. So now G dash is equal to Gm divided by R square, right? So as you move away from the earth, what happens? Acceleration due to gravity decreases inversely like this, 1 by R square. So the correct option is here, fourth one. Okay, correct graph is the fourth one. Correct option is D. Yeah. Question number 17. If the charge on an object is doubled, then the electric field becomes, direct question, right? Electric field E is equal to K into Q divided by R square. So electric field is electric field depends on the charge on the object, right? So when you increase the charge, what happens? Electric field will also increases. So if you double the charge on the object, so then electric field will also be doubled. So the correct option is B. Next question, question number 18. SI unit of electric flux. Electric flux phi is equal to E into A into cos theta, right? E into A into cos theta. There is no unit for cos theta, right? SI unit for cos theta, right? So it is a dimensionless. Now phi or unitless, right? So now electric flux phi equal to, what is the SI unit of the electric field? Newton per coulomb. And SI unit of area is meter square. So Newton per coulomb meter square. Correct option is A. Next question, question number 19. 4 equal charges Q each are placed at 4 corners of a square of side A each. Okay, let us draw the square. Q, Q, Q and Q. A and A. Yeah. Work done in carrying charge minus Q from its center to infinity is, okay, initially charge is at center of the square. So then the charge Q is moved from center to the infinity, right? So we need to find the work done to move a charge from center of the square to the infinity. Yeah, simple, right? So find the potential energy of the minus Q at the center of the square, and then potential energy of the minus Q at infinity. Potential energy of the minus Q at infinity is 0, right? So find the potential energy of the minus Q at the center of the charge, then take the difference, right? So work done is equal to change in potential energy, that is final potential energy minus initial potential energy, right? So now work done is equal to final potential energy, right? That is potential energy at the infinity, 0, minus initial potential energy, that is potential at the center of the square due to 4 charges, right? Potential at the center of the square due to 4 charges, okay, V into minus Q, V into minus Q, charge of the test charge, right? That is minus Q. So now W equal to Q into V, right? So now W is equal to Q into V, that is potential at the center of the square, right? So potential at the center of the square due to 4 Q charges. What is the distance between the corner of the square, any one corner of the square to the center? That will be A divided by root 2. Diagonal is root 2, root 2A. So root 2A by 2, that is A by root 2, right? So now KQ divided by A by root 2 due to this Q charge, right? So there are 4 charges, right? Now into 4. So now W is equal to K is 1 by 4 pi epsilon naught. So Q square into 4 divided by 4 pi epsilon naught into A. Here in numerator root 2 is there, right? 4 will get cancelled. W is equal to root 2 Q square divided by pi epsilon naught A. The correct option is here B. Yeah. Next one, question number 20. A parallel plate capacitor with air between the plates has capacitance of 10 picofarad. Okay, so when there is no dielectric material, the capacitance of the capacitor, parallel plate capacitor, is 10 picofarad. So this is C. C equal to 10 picofarad. The capacitance, if the distance between the plates is reduced by half, okay, distance between the plates is reduced by half, right? So initial distance is D. Now new distance is D by 2. Okay, and the space between them is filled with a substance of dielectric constant 4 is. Okay, so now space between the plates reduced by half, right? And the space between them is filled with the dielectric material, and dielectric constant of that material is 4, right? Okay, so we know that capacitance of the parallel plate capacitor when the dielectric medium is inserted, C dash is equal to epsilon naught A into K divided by D. Okay, yeah. So now C dash is equal to here the distance, sorry, the separation between them reduced to half, right? So now epsilon naught AK divided by D by 2. Okay, so now C dash is equal to 2K A epsilon naught divided by D. A epsilon naught divided by D is the capacitance of the parallel plate capacitor when there is no dielectric medium between them, right? So now C dash is equal to 2K into C. C is 10 picofarad. So C dash is equal to 2 into 4 into 10. So C dash is equal to 80 picofarad. So the correct option is A. Yeah. Next question, question number 21. A slab of material of dielectric constant K has the same area A as the plates of parallel plate capacitor and has thickness 3 by 4D. Okay, thickness of the dielectric medium, okay, is 3 by 4D, where D is the separation between the plates, the change in capacitance when the slab is inserted between the plates. Okay, this one is simple, right? So C dash is equal to direct question, okay, when the dielectric material of thickness T inserted between the parallel plate capacitor, the new capacitance will be C dash is equal to epsilon naught A divided by D minus T minus T divided by K. Okay. So now C dash is equal to epsilon naught A divided by D is, okay, here D minus T is 3 by 4D. 3 by 4D minus here 3 by 4D divided by K. Now C dash is equal to epsilon naught A, right, divided by D minus 3D by 4 into 1 minus 1 by K, 1 minus 1 by K, right, 1 minus 1 by K. Okay, here let's open the bracket, right? So 3D by 4 minus 3D by 4K, right? So now 3D by 4 D minus 3D by 4 is D by 4, right? So C dash is equal to epsilon naught A divided by D by 4 minus 3D by 4K, right? Okay, so now C dash is equal to take D as common, right? Take D by 4 as common, okay? So now epsilon naught A divided by D by 4 into 1 minus 3 by K, right? Sorry, this will be plus, okay? This will be plus. So 1 plus 3 by K, 1 plus 3 by K is K plus 3 by K, right? K plus 3 divided by K. Finally, C dash is equal to 4K epsilon naught A divided by D into K plus 3. So the correct option is D. Yeah. Next question, question number 22. A parallel plate capacitor has uniform electric field E in the space between the plates, if the distance between the plates is d and the area of each plate is A, the energy stored in the capacitor is, again the direct question, right? Energy stored in the parallel plate capacitor, okay, energy stored in the capacitor U equal to half CV square, okay, yeah, U equal to half C is epsilon naught A divided by D into V is potential difference across the capacitor, right? So that is electric field into separation between the two plates, that is E into D squared, E into D whole square, that is E square into D square. So D will get cancelled, right? Now U equal to half epsilon naught E square into A into D, okay, A into D. So the correct option is C. Next question, question number 23. A strong magnetic field is applied on a stationary electron, then the electron moves in the direction of the field. Wrong. Electron remains stationary only, right? Isn't it? Why? Because there will be no force acting on the electron. If it moves with some velocity v, then it experiences some force. So the correct option is B. Next question, question number 24. A charged particle having drift velocity of 7.5 into 10 to the power minus 4 meter per second, that is Vd, in electric field of 3 into 10 to the power minus 10 volt per meter, mobility is, okay, so mobility mu equal to Vd, that is drift velocity, divided by electric field, right? So now mu equal to drift velocity is 7.5 into 10 to the power minus 4 whole divided by, okay, divided by 3 into 10 to the power minus 10. So now mu equal to 2 into 10 to the power, sorry, 2.5, okay, 2.5 into 10 to the power 6, 2.5 into 10 to the power 6 meter square per volt per second, okay. So the correct option is B. Next question, question number 25. The temperature dependence of the resistivity of a semiconductor is given by, the direct question, the correct option is C, okay. So this is the graph, resistivity versus temperature graph, okay. Next question, question number 26. A boy has two spare light bulbs in his drawer. One is marked 240 volt and 100 watt, and the other is marked 240 volt and 60 watt. He tried to decide which of the following assertions are correct. Okay, let's read the assertion. The 60 watt light bulb has more resistance. Okay, let's see. Here, let's see the resistance of each bulb. So now the bulb first one, resistance of the first bulb, right? Power and voltages are given, right? Power and voltage given, right? Isn't it? We know that power P equal to V square divided by R. Now R equal to V square divided by P. For first bulb, here the voltage rate is 240, right? So 240 into 240 divided by 100. So which is equal to 2.4 into 240 ohm, right? So resistance of the first bulb. Then resistance of the second bulb, 240 into 240 divided by 60. So this will be 4, right? 64s are 240. So resistance of the second bulb is equal to 4 into 240 ohm. So resistance of the second bulb is more, right? So the 60 watt bulb has more resistance, correct? And therefore burns less brightly. This one is also correct, right? If the resistance is more, then it glows less brightly, right? So the correct option is A. Okay. 100 watt bulb has, light bulb has lesser resistance compared to the second bulb, that is 60 watt bulb, right? So it glows more, it glows highly or more, right? Yeah. Question number 27. A conductor carries current of 50 microampere, okay, I equal to 50 microampere. If the area of cross section of the conductor is 50 millimeter square, that is A, then the value of the current density is, Direct question, right? Isn't it? Even in board also they won't ask these kind of question. Yeah. So current density J equal to current divided by area A. So current density J is equal to current 50 into 10 to the power minus 6 divided by area is 50 into 10 to the power minus 6 meter square. So these two will get cancelled. Current density is 1 ampere per meter square. So the correct option is B. Next question, question number 28. In the series combination of n cells, each cell having EMF E and internal resistance R. If 3 cells are wrongly connected, okay, 3 cells are wrongly connected, then total EMF and internal resistance of this combination is, okay, so total resistance is NR, okay, let us find total EMF. Here the total EMF or net EMF, E net is equal to, here 3 cells are connected wrongly, right? So now the remaining cells are connected in series, right? Isn't it like this? And so on. N, so there are n number of cells, right? So 3 cells are connected wrongly, right? Isn't it? 3 cells, right? So then the remaining will be n minus 3 cells, right? So net EMF will be, net EMF is equal to n minus 3 times E minus 3E. So net EMF is equal to n minus 6E. Okay, and total resistance, internal resistance is NR. So the correct option is D. Next question, question number 29. Okay, a proton and alpha particle enters in a uniform magnetic field perpendicularly. Okay, let's say magnetic field is into the plane, and proton and alpha particle enters into a magnetic field perpendicularly with the same speed. Okay, perpendicularly with the same speed. The ratio of the periods of both particle, that is Tp by T alpha. Okay, so this is Tp by T alpha will be. So we know that the time period or time taken by the any charged particle to complete one circle, right? Time period T equal to 2 pi m divided by qb. 2 pi m divided by qb. So now Tp by T alpha is equal to, anyway 2 pi will get cancelled, right? Mass of the proton by charge of the proton into magnetic field B divided by mass of the alpha particle divided by charge of the alpha particle into B. So now Tp by T alpha is equal to, here 1 by B will get cancelled. MP divided by M alpha is 4 times MP. MP is mass of the proton, right? Mass of the alpha particle is 4 times mass of the proton, right? Into, here Q alpha is 2 times charge of the proton divided by Qp. So Qp will get cancelled, MP will get cancelled. Tp by T alpha is equal to 2 by 4, that is 1 by 2, or 2 is to 1. Sorry, 1 is to 2. 1 is to 2. Sorry, 1 is to 2. 1 is to 2. The correct option is A. Next question and the last one. A tightly wound 90-ton coil of radius 15 cm has magnetic field of 4 into 10 to the power minus 4 Tesla at its center. The current flowing through it is, again the simple one, right? Magnetic field at the center of the coil, B equal to N into mu naught I divided by 2R. So what is N? Number of turns. Mu naught is magnetic permeability in vacuum. I is current in the coil. R is radius of the coil. B is magnetic field. So we need to find I. I equal to 2R B divided by N into mu naught. Okay, 2RB divided by N into mu naught. So now I is equal to here 2 into R is 15 centimeter, 15 into 10 to the power minus 2 into B is 4 into 10 to the power minus 4, 4 into 10 to the power minus 4 divided by n is 90 into mu naught 4 pi into 10 to the power minus 7. So now solve this, you will get I equal to 1.06 ampere. So the correct option is A. Okay, yeah, that's it. Thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.